graph f of x equals 2 over x minus 3 plus 1. Okay, the way we approach this is we need to graph the horizontal and vertical asymptotes first. So how we find the vertical asymptotes is looking at the denominator and seeing what makes the denominator equal to 0. So we have x minus 3 equals 0. So when we solve that, it's x equals 3. So we have just one vertical asymptote, and that's at x equals 3. So we're going to graph that. Okay, also we have a horizontal asymptote. Now, if you look at the function, we have this plus 1. If that wasn't there, if our function was only 2 over x minus 3, then the asymptote would be just at y equals 0. But the plus 1 indicates a shift up, so everything shifts, the whole function, including the asymptote. So now our asymptote is at y equals 1. So let's graph that. Okay, so now that we have the asymptotes, we need to figure out some points. And how we pick those points is we look where our vertical asymptote is, and then we pick a couple of numbers on the left and the right of the vertical asymptote. So let's make a little table. Okay, so a couple of numbers on the left side of 3 are, let's pick 1 and 2. Those are the obvious ones. And then a couple of numbers on the right side of the asymptote, which are 4 and 5. Okay, that's all we need, really. Sometimes you might want to pick another 1 or 2 numbers if it helps, but in this case, it'll be enough. So we need to plug those into our function and to calculate each one of those. So when we plug in 1, so we have 2 over 1 minus 3 plus 1. So we get 0 right there. When we plug in 2, 2 over 2 minus 3 plus 1. So we get -1. When we plug in 4, 2 over 4 minus 3 plus 1 equals 3. And then the last one, 5, 2 over 5 minus 3 plus 1 equals 2. Okay, so we graph those on our plot. So we have 1, 0. We have 2, -1. We have 4, 3. And 5, 2. Okay, and remember our graph in this case cannot cross across the asymptotes. So as we kind of connect these, the graph is going to approach our asymptotes and continue, but it doesn't cross it. And the same way on the other 2 points, you connect them, and your graph goes through those points and approaches the asymptotes, but doesn't cross them. So here's our graph for f of x equals 2 over x minus 3 plus 1. Okay, graph f of x equals x plus 3 over x plus 2. Okay, this is a slightly different function. Now we have an x on top and the bottom. So it works the same way, except for the horizontal asymptotes. We calculate those a little differently in this case. Okay, so again, we start with the asymptotes. The vertical one comes from the denominator, so x plus 2 equals 0, so x equals -2. Okay, so this is our vertical asymptote. So again, we have just one because it's just an x. If it was x squared and you solve it, then you usually have 2. So also, we need to find the horizontal asymptotes, and again, as I mentioned, those get calculated a little differently. So when you have an x with the same exponent, which is x to the 1 in this case, then you just look at the number in front of the x and use that fraction. Now in this case, we just have 1 here and 1 below. So the fraction is 1 over 1. So our horizontal asymptote is just equal to 1. Okay, so I'm going to graph that. Okay, so now we want to graph a few points, and just like before, we're going to graph a few points to the left side and a few points to the right side of our vertical asymptote. Okay, so I'm going to do -4, -3, -2, not -2, -1, and 0. Okay, so when I plug in -4, I get 1/2. Okay, when I plug in -3 in our equation, I get 0. When I plug in -1 into the equation, I get 2. And when I plug in 0, I get 3/2, or you can think of it as 1.5 if you don't want to do fractions. So let's plot those. So at -4, we have 1/2. -3, we have 0. At -1, we have 2. And at 0, we have 1.5. Okay, so again, just as before, connect those numbers and make your graph approach the asymptote. And you can just put arrows at the end if you don't want to keep drawing the line. Likewise, with the other 2 points, let the graph approach the asymptotes. Okay, so let's say your problem tells you to find also the x and y intercept. Now, in this case, we already see what it is really easy from the numbers that we pick, but should you have a problem where that doesn't happen, remember that you get your x-intercept from the numerator of this function. So the numerator in this case is x plus 3. So just set that equal to 0, and you're going to get that x equals -3. So that's our x-intercept. And you can see in our graph that is true right there. At x equals -3, the graph crosses the x-axis. Now if you want to find the y-intercept, remember that's when you plug in 0 for the x's. So in this case, f of 0 equals 0 plus 3 over 0 plus 2. And that's 3/2, or 1.5. And again, if we look at the graph, that's indeed where our graph intercepts it. Now, again, in this graph, we could easily see that, but if the numbers that you pick for a problem don't give you that answer, go ahead and do the calculation.